like yesterday, like in last session, we have discussed about like how decision tree works and like how it can be used for classification, right? So, and like we also have discussed like there will be few challenges regarding decision tree, like it may overfit sometimes, and that was the case, right? So, there are few methods which can be used to kind of like overcome this problem. So let us discuss about those. Okay, so one of those problems is like bagging, and one more is like boosting. So okay, so let's go further and then discuss about like these things. So bagging and boosting like will look like slightly similar, but they are different approaches. So let's discuss about bagging first. Okay, so what bagging is like let us say you have certain training sets. Okay, you have some samples of training data here, and similarly you so what we did in like decision tree, we have taken the whole training set, and we have trained a classifier, right? Like we have trained one decision tree classifier, and need not be just decision tree. This can be applicable with others as well. So let me write generically as classifier, or even like regression also. So we have taken this, and finally we got an output, right? So this is how we did it. Like this is a train set, and which we gave it for the classification, like try to fit the model based on that, and after that, like we got their output. So, but what bagging will do is like bagging is like what is the first problem like which we face during decision tree classifier? Like you have a set of training examples, and when you try to fit a decision tree on this classifier, what we thought is like this may have some overfitting, right? So this may have some overfitting. That's what we have seen here. So so what can be done? Like because if you see this point, like so what we can observe here is so if entire training data is seen to the classifier, then it is getting fitting to that model. Okay. So what we can see here is like this is a training set. We have shown the entire training set to the classifier, and we are training an output, right? So instead of that, what will we can do is we take a sample of this, like not the entire set, like we take a subset of the training set, and let's call it training set one. Okay, so and how we'll generate this training set is like we randomly sample from this training data. Let us say you have 100 rows, okay, 100 rows in total. So out of it, maybe you take again you can take 100 rows or like 200 rows or sorry 1000 out of this 1000 rows you can take like how many you want. But what we do is we also train a sample it with replacement. So sample with replacement. So this is like here we do a sampling with replacement. What sampling with replacement actually means is, so let us say you have some data like 1, 2, 3, 4, 5. Okay, this is, let us say this is your set, and out of which you want to sample some data. So how you will be sampling is you can take randomly take any like random sampling with replacement. Like if it is like just random sampling without replacement, you just pick like few numbers from here, right? So let me pick like 1, 2, 4. So this may be one subset, but random sampling with replacement means actually the repetition is allowed. So in this case, so what will happen here is, so this is without replacement. So if it is with replacement, like means like the number can come multiple times as well, right? And it need not come as well. Like so this can also happen. So something like this. So like depending on number of like we can specify the length, like how much length we want, right? Like anyway here as well, we'll be specifying like how much length should be there in the sample size. So in that, if it is with replacement allowed, so these numbers can repeat again, right? Like what we are randomly picking from those set of numbers, like this numbers can repeat again. So that's what actually with replacement means. So without with replacement or with repetition those things. So similarly, like without doesn't have that option. Okay. So let's take it aside. So what we can see from this is like here in bagging, we do it like sampling with replacement. Okay. So, and what we do is we try to create one more like kind of a subset of this training set. So you will have some zeros, some like maybe the length you can decide by yourself, or how much it can be. It doesn't matter, but the number of rows will repeat so that it we can even let's say you have 1,000 rows, we can even get a 10,000 length of your training set, because as repetition is allowed, maybe each one some of the data points will appear 20 times, some will appear like 5 times, some will appear 10 times, like this. So we will be getting some set. Okay. So and you train a classifier and you get an output. Similarly, not just one, uh, we'll again do the same. So and with a new training set, this is training set 2. Maybe length is again like your wish, and you train a classifier and get an output. Similarly, one more. These are like different sets. Like it need all these three need not be same, and it should not be same as well. Like if you want to have the same values, then why you want to? If it is same, then your output will also be same, right? So you actually want some different sets. So this is training set 3. So on, you can have multiple numbers, like n numbers you want. Okay. So any number you want. Okay. So taking this output, you have some output from one model, like second model, third model. So all these three, all model will have like different outputs, right? Some will predict it as like class 1, some will predict it as class 2, something like that. So what we'll finally do is like we have to aggregate all these outputs, right? So all these outputs we have to aggregate and finally get one final aggregated output, right? So this is how finally we'll do it. So what it will be is like this, we take some kind of logic like the majority, like these are like, let us say there are 10 here, okay? So out of this 10, what majority says? So that we can take majority vote. Okay. So R, we can also take an average output. So, or there are like many, a few other ways as well, but these are two popular things. Like we will decide like which strategy we'll be following. So what we'll do is like we'll uh, take like all these classifiers. These classifiers will be taking like what, let's talk about one example. So let's talk about maximum. Okay. So let's say there are like 5 classifiers here, and out of which the one is giving 1 1 0 1 0. Okay. So this is our like first model is like predicting as 1, second one is 1, and third one is predicting as 0, fourth one is 1, and fifth one is 0. So in this case, we'll finally take like how many majority, what is majority saying? So majority is saying it as 1. So take it as 1. So this can be one way of aggregating like various models. So finally we get this. Okay. So this is about bagging. So what we get is, instead of like we may think like if it is like one single classifier, right? So it may overfit to that, like it will learn like exactly what training data is, and it may remember the training data, right? So that was one issue which we felt. So here we are not exposed, like for each of the model, like we are not exposing entire training data. We are exposing only partially, right? So we take like similarly like various models, and each model we are giving different kinds of like data sets. Okay. So and like it is predicting like different outputs. So and all these outputs we are aggregating it, right? So we are aggregating all these outputs and finally getting one output. So this case, what will happen is it will reduce overfitting. Okay. So like bracket, like we can also say it as variance, like variance will be reduced. So it may perform very well in when in testing data, because like we are not overfitting it. So this is what bagging will do. Okay. So and these things like where we are actually taking like multiple models and finally getting an output, right? So we call these as ensemble methods. So this is like a very much popular way of doing it, ensemble method. So instead of training a single model, they will train multiple models and they will. So this is what we have here. So like what we have seen is this kind of method, we call it as ensemble methods, right? Okay. So where you aggregate like various inputs, like various models, and you finally use that for prediction. So these kind of models, like we call it as ensemble. Okay. So where you can combine like various kind of models, like one can be logistic regression, one can be a deep learning model, and one can be what you say like decision tree, something like this. And finally, you aggregate all those models, like give a different set of training data, and then you train a model on that, like, and finally aggregate the output, right? So this is called like ensembling. Okay. This is very popular method, like which people use most of, even if you take these competition, right, data science competitions where mostly in casual. So ensemble methods wins most of the like prizes, like usually the winners will use like the ensemble methods. Okay. So this is one thing, like similarly, before going into like the boosting method, let's take one example. Like there is one, there are very many, like, but I'm talking about one of them. So an example for this. So there is one model like which was like and some bagging of your decision tree classifier. So decision tree classifier. So this is called like this particular model is called random forest. So you can actually deduce from name itself. It is like a forest, right? So here it is tree. So when you will have like multiple number of trees, like we call it, like we can take it as a garden or like forest in this case. Okay. So what it says is like maybe that's why this name has come. So what we do is just like how we have told, right? So we can do something like this. We'll get a training set one with replacement, and similarly training set two, training set n. Okay. So all these, if you give to a decision tree here, decision tree, decision tree, and so on, like to a decision tree models, and you get an output from each of them, output n, and you aggregate all those outputs and get a final output, right? So usually this is our like bagging, right? So bagging of a decision tree classifier is, right? So where you have randomly sample like data sets and with replacement, and then train a classifier, like every classifier, if it is like decision tree. So and you get an output. This is like bagging of your decision tree classifier, right? Decision tree classifier. So like how random forest is, like if it is exactly, it will be slightly different. It is like same but slightly different. So what it will also do is, along with like bagging of data, it will also use, there will be bagging of features as well. Okay. So what it will actually do is, so let us say you have a few features. So x1, x2, x3, so on, x10. Let us say these are your features. So taking these features, let's say this is a y which you are predicting. So out of these 10 features, right? So maybe you don't know, like few features will be useful and few may not be useful. So what you'll try to do is, like you'll like previously what we did. Let us say you have 100 rows, 1,000 rows here. Out of these 1,000 rows, you sampled like few of the rows with replacement and made it like one training set, right? So similarly, what we do here is, we will sample out of those, here it is 10 features. Out of these 10 features, you maybe sample like 4 features at a time. Okay, maybe x1, x2, x3, and x7. Okay, this is one training set. Similarly, x1, x2, x3, like need not be x3 here, x6, and x10 here. So randomly pick like few of the feature sets. Now previously it is training set. Now it is feature set 1, feature set 2, so on. It can be like, you can your wish, like how many you want. Feature set 100, let us. So where you have something like x2, x9, x10. Okay, something like this. So it can be anything. It is random, right? Like completely random, right? So you can pick like how many you want, and each of these things you train a decision tree classifier. Similarly, decision tree classifier. Similarly here as well. So and each again, next the story is same. Like you have to get output from each of those things. Let us say this is 100. This is okay. So and you aggregate all together and finally get one output. So if you do this way, in this case, even for features, we will be knowing like which feature, maybe some features are very important, some features are not at all important, right? So in that case, you will be knowing like actually getting to know which, but in case if there are very good inputs, okay. So let us say this feature set 1 contains very important feature. So and there is one more thing like feature 2 which contains like misleading features. So okay, maybe some x6, x7 are like misleading, x6 and x8 are misleading features. So here if you take all, maybe that may reduce the performance if you take all the features at a time. So maybe if you do like this, all those features won't be contained in all, right? Like there will be many feature sets which doesn't contain such kind of uh, like means like irrelevant features. So what it will do is, that particular training set which doesn't contain these kind of features, so those will perform well. So if, because like we are doing random sampling at like multiple number of sets, those will be in majority, and then you will finally get like better output. Okay, so this also, because of this thing, we are having like less number of features, and we are trying to predict and like see at multiple, like get the opinion from multiple models. It will be like surely like reducing the overfitting. Okay, so because we are using like less number of features at each of these things, right? So because we have seen in previous sessions that using more number of features will actually have a chance of overfitting, right? So here for each of these model, like we are using like less number of samples, but we are actually using all 10. But if you compare like each model, like it is taking like very less features. Okay, so this is what about like random forest. This is like one of like popularly used algorithm. People, instead of they mostly they won't use decision tree for classification. They'll go for like random forest because this has like very good advantage of ensembling, and it reduces overfitting, right? So this is one. This is about bagging. Okay. So now let's talk about boosting. Okay. So what boosting actually is? So if you see boosting, we have seen bagging till now. Now what boosting will do is like it is slightly different. So where we'll be taking data sets. So previously what we did, we have done random sample with replacement, right? So boosting is little different here. So boosting, what it will do is, so let's say again like this. So actually, the concept of boosting, let me start with that. So what it will do is, like this is the training set. So training set will remain the same most. Okay. What it will try to do is here, it will let us say you have some weak classifier. Okay, weak classifier is like classifier. Okay, so what a weak classifier means is like it is not very accurate. Okay, so yeah, it is not actually able to do well on your data, and it is mostly like underfitting. Like you have very small model and like complex data, in the sense like if this is let's take the same training set, and this training set you try to learn a decision boundary and you got somewhere like this. Okay, it is let's take this scenario, and you got something like this where it is not actually able to classify well. Okay, so in this case, this is underfitting, right? So if this is a scenario, what we can do is we take, just like in bagging, how we have taken multiple number of classifiers as and finally got a like better output. Similarly, we combine many weak classifiers. We combine many weak classifiers to get a strong classifier. Let's see how it will be done. Okay. So what we do is we combine weak classifier 1, classifier 2, and so on. We take all these as again as input, like maybe a weighted sum, like instead of direct, like it will be a weighted sum, means A1, A2, so on, AN. Okay. And finally we get an output. So this will be your actual classifier instead of this is like boosting classifier. So we'll be taking a combination of various weak classifiers, and finally we get a better classifier. This concept is called boosting. Okay, so we use this boosting concept in here, like let's say like how we'll be training such kind of thing. Okay, let's see that. Okay, so what we'll do is in step one, we take the entire data set, take entire training set. Okay, so let's call it D1. And what we'll do is we'll be training a classifier, train a weak classifier. So weak classifier is nothing but just like any classifier. Usually, weak classifier in the sense less complex one, and there are chances for underfitting over there, right? So, so something like this. We have a model, and taking that model. So, okay, so just a minute. Okay, we can take this as so let us say this is the data you have. Let me keep it. It will become a little complicated. So let me do it like this. So let us say this is your data which you have. Okay, so this is the data. So using this data, you are you are training a model like for weak for classification. Okay, so and as I mentioned you, this classifier won't be accurate. So it, because it is weak and a simpler model. So what we'll have is maybe do like this. Okay, so it will do a classification like this. So in this case, what will happen is it has classified few of them better, and it has misclassified one cross here, and it has misclassified three bubbles here, right? So okay, so this is one weak classifier. So next, what we'll do is we'll take this, take again entire training set, but with we will increase the weightage for the misclassified ones. Okay, increase weightage for misclassified ones. So I'll tell you like how misclassified data. So previously, if you take the previous sample, if you have to, let me draw the same here. Okay, there are three here. Okay, so this is how previously it is, right? And let me draw it with green previous one. It is like this. So and the few are like misclassified. So what I'll be having is this is one misclassified, and these are the ones which is misclassified. Right? I am highlighting with making it thicker. So what it will happen is for these data set, there will be more weightage. So in the sense, more weightage can be like different ways. Maybe increase loss to a factor for that particular data, or maybe use it like multiple times, or it can be anything something like that. Okay, there can be many ways. Like only thing is, it will stress that model to actually do better on perform better on that data set. Okay, so if you do that way, so what will happen is, let's see this case. Okay, so then for that particular case, let me, because it is an weak classifier, so it will try to underfit, right? So this darker positive is there, right? So it should be on one side, and these darker rounds should be, so these darker rounds should be on other side, right? So because it is an overclass underfitting, it will be like weak classifier, it will try to underfit. So what will happen is something like this will happen. Okay, so this is a classifier which it will try to do, because it will have very high priority to means separate this thicker plus and thicker rounds in a different class. So it will have something like this. Okay, so but what happened, it still misclassified few things, right? So it will be a next iteration. Now take entire set with weighted weightage, right? So we call it D2, entire train set with again increased weightage to misclassified. Misclassified data. So now what is actually misclassified here? So taking this thing. So let me draw again. So that is a problem. Okay. Okay. So this is what we have, and this is how it has classified now. Okay. So using this, now what are actually misclassified is these points. So these are all fine. Plus, surprisingly, all pluses are fine here. So what it has misclassified is for this. So let's not have it like this, like maybe have some just for kind of explanation, let me have this here. So uh, okay, it has done a classification like, okay, so nothing, just to have like both values here, and you have one misclassification here. So this is a thing which happened over there. Okay. So now the new data should give like more weightage to these misclassified things. And finally, what will happen is like goal is to have like classifying this thicker ones, right? So you'll have somewhere like this, something like this maybe, right? So now, okay, so this is output from D3. So what we'll do is like finally, let's say like at this point again, like there will be few misclassifications, right? So we can't avoid that. So again, what we have as a misclassification, we have like there are like many, right? Because like each of them is weak classified, right? It is like weak classifier. So it will actually do misclassification, right? So we can't actually assume like if you multiply iterate with like different kinds of scenario, like you will get like better classifier. So always there will be few misclassification. So now what we do is we combine. It can extend like for multiple iterations. Like now we have taken only three iterations here, so we can have like multiple models just like the other than this three classifier. So what we do finally is like we'll be like combining each of these. So this is like classifier one, classifier two, and classifier three. So finally, your final classifier will be a combination of these three. So how it is actually like it can be easily understood like by after pictorial representation of this. So what it will do is so let me draw the same data here. Okay, so 0, 0, 0, 0, 0, 0. Okay, so what it will do is it will use these three. Okay, it will combine these three classifiers. So and make a new classifier, right? So there is something like this from that one, and something like this from other. So actually, like I'm very bad at doing here, like, but actually, it has found some way like this. Okay, what I'm trying to do here is like combine all those three classifiers and finally get one classifier, right? So it actually has done something like this. Okay, not here. So let me draw slightly here. So there will be like still there will be few misclassifications, but comparatively, like it will reduce. Okay, so this is what if you combine all the three, finally you may get some graph like this. It may actually is combining like few, right? So you may not get like actual way like one a single straight line or something, because we are combining one something like this, and something like this, three of them together, where you have like a graph. Okay, like let's see like this. Okay, so here I'm trying to make it. What will happen here is the our new classifier will be a combination of these classifiers, right? So and finally what you get is this thing. So you'll be able to classify much better compared to previous thing. Like so maybe there will be slight misclassification here, but still like it is like much better than any of these classifiers, right? So what you have here is like you'll have by taking a combination of like various weak classifiers, we'll be getting a strong one classifier. Okay, so this is how it is done. So and we finally get a strong classifier. right? So what this is done, like what this has done is like it has reduced overfitting, sorry, underfitting. So underfitting is actually what underfitting is actually is it reduces bias. So this is about like boosting classifier. There are very popular boosting classifier. One of them is like XGBoost, like which people use it even now in many other projects. Like XGBoost, like will do very well actually in many cases. But there are chances like if you do it more right. So what you are actually doing is you are making it to like fit exactly to your training data, right? So it is like slightly prone to overfit, so that you should be careful and in evaluating these models. So because like it may overfit, so you should always be like cautious that always like evaluate on testing sets such that it doesn't overfit. So because like we what we are trying to do is like here we are having one like here like maybe they are misclassification, right? So on misclassification you are training again like on misclassification you are training again, so on like you what you are trying to do is you are trying to exactly fit your training data. If you do one more thing, maybe here it is slightly misclassified, maybe that also won't come, right? So such kind of scenarios you can actually uh, like face like when, because like chances are there like it may overfit. But if you see this, like one big advantage here is if you take this kind of data here, okay, the data which is shown here, so this data you can't separate it with a single line, right? So if you take this data, so if you take this data, any kind of data, it need not be that example, it can be anything like this, okay. So and you have places here and you use a linear classifier like kind of thing. So how can you separate it by a single line? Is it possible to do it like when you try to separate it over a single line, maybe you'll do something like this, right? But there are many misclassifications here. It can't exactly do it. So in this case, we say it like under, right? Because it your model complexity is not enough to classify this. So in that case, it is underfitting. So maybe if you use multiple classifiers, one would give some result like this, one would give some result like this, one would give some result like this, one may give something like this, and finally your final model will be somewhere like this, right? So in this case, like this actually your if you take that red decision boundary, that is like model which is like for boosting model. Okay. So, and this green are weak classifiers, weak classifiers. So, if you take the combination of all, what happens over there is it is actually able to classify between this rounds and process, right? So, what we finally get is a better classification. But there is a chance of overfitting, but it actually, but if you see main advantages, it is not underfitting at all, right? So there are no bias on the training data. Its error is like almost zero. So this is what like use advantage of using boosting. So yeah, this is about it for about like bagging and boosting. So do you have any doubts?
Yes, one question. So
Mm-hmm.
even for boosting, you will take the data randomly, right?
Actually, we can take entire training set, like not randomly,
Mm-hmm.
we'll use entire training set, or there is also like in some kind of literature, it is shown that like in articles, like take only misclassified data and train the model. So that is also fine. But we don't, because we don't do a random sampling here, right? So because
Mm-hmm.
in first case we take the entire data set, and in
Mm-hmm.
second case, like after one iteration, what we took is we have given like more weightage to the data where it is like
Mm-hmm.
misclassifying. Okay.
Mm-hmm. Mm-hmm.
So, but we take like we can take the entire data set. Like we are not taking subset here. We are taking the entire data set. Or what we do is like we main thing is like we have to give more weightage to the misclassified data, or maybe only take the misclassified data and train a model. That is also fine. That is
No,
also
but
acceptable.
how we know that or how the model knows that it is misclassified data?
No, model doesn't know. It is
Mm.
us. We should be doing it. See, like after the first step, you also give the
Correct.
ground truth, right?
Mm.
Uh, yes. So what we also know is like we also know the ground truth here, right? So you have x and y. So you have x1, x2, x3, so on, and y here. We actually like once the training is done, we calculate how much is the error for training, like how much is the accuracy, if you can remember. So let us
Mm.
say these
Correct.
data points, uh, these data so what we can have here is like maybe this is like class one, this is class two, this class zero, class one, like this. And what it is predicted is like depending on this, this is predicted as one, this is predicted as one, this is predicted as one, this is zero. So this way it has done. Okay. So you know this is misclassifying, this is misclassifying, this is misclassifying, right? So maybe it predicted as one. Here it is not misclassifying. So these three are misclassifying. So you give more priority to this data set. Did you get the point?
Yeah, yeah. Okay,
Okay.
so for the next boosting, so we will this will be the input. This
Uh,
data set is an input, and you calculate the
you
classifier.
again train the model. Yeah, yeah. Again train the
Mm-hmm.
model and see how it will do. Okay.
Mm-hmm.
So so that is how it is done across like multiple iterations you can go for, and then combine all those models, finally you get this. So this is much better example, I think, like when I draw this. So first one, it is like doing like misclassifying these rounds, and the second classifier, so this is classifier 1, classifier 2, clf 3, and this is 4. If I miss something, yeah, this is 5. Okay, so this is how it has classified, and we are taking all combinations and getting this thing. So yeah, this is about then like what we have is finally we don't have this underfitting because of this. So we actually got a non-linear classification like for this data, right? So this is about it for boosting.